Hello all, good morning. Now today's lesson I want to explain you Cadence. So what is the Cadence tool and how it will be worked? Among the major tools, Cadence has Allegro, OrCAD, Sigrity, Virtuoso and last but not least Spectre. Now Allegro and OrCAD are used to PCB design and analysis. Security we have to use for signal integrity and power integrity analysis. Virtuoso and Spectre are used for the custom and mixed signal IC design. So this video actually focus on the IC design process. So I want to explain you main Virtuoso and Spectre. Virtuoso of family of tools provide a schematic editing, layout design of the circuit, DRC, which is known as design rule check, which is very important, and finally layout versus schematic, that is LVS. And Spectre is a Cadence Spice tool for circuit simulation, and it is integrated in Virtuoso platform. It provides a bunch of powerful analysis tools such as DC, AC, and transist analysis. So S parameter analysis for linear circuits, harmonic balance, PSS means periodic steady state, or QPSS, quasi-periodic steady state analysis for non-linear circuit, and many more. One more for time domain and frequency domain envelope analysis and noise analysis, and many more. Basically, it provides details, transistor level analysis in multiple domain. The fact is, Cadence does not run in Windows because most of the Cadence tools are Linux based and run on a server. Usually, users need to log into Linux server to initiate Cadence from their workstation, and the Linux server can be accessed through any remote login, any remote login client tool through SSH network protocol like shown in the figure. So first, what you have to do, connect to Cadence server in a lab. Generally, you have to connect with the Open VPN. So please connect, and it is getting, and you have to check it connected or not. So look at SSH shell terminal, it look like this. Actually, we need to connect this server, so you need to write down a few lines of code to connect to the server. First is compulsory for username and password, and a few lines more code. Look at, it's written over here. Now look at this Virtuoso Cadence window will open. This is called Command Interpreter window, or CIW in short. The title bar of the CIW contains the name of the workbench that you are running. Since I am running virtual search, so the name is Virtuoso written on the title bar. Now let's open Library Manager from Tool option. This is the center hub of your virtual platform where you can see all the libraries. The Library Manager is divided into three parts: Library, Cell, and View. To understand how Cadence treats its project files, you need to know its hierarchy. Library is the topmost entity in the Cadence, under which there can be multiple cells. Now, each cell can contain partial components of a larger IC. This approach allows more control in design and troubleshooting circuits. Again, each cell can contain multiple views, for example, schematic, layout, and schematic, symbol, and layout views. Now let's create our very first library in Cadence. Cadence Virtuoso. Go to File and then New and then Library. Give a library a name, for example, intro underscore nm, then OK. This window is asking for the ICPDK file. PDK means what? PDK is a short form for Process Design Kit. Is the heart of the IC design process because these files are given to the IC design engineer by the semiconductor foundries such as IBM, TSMC, and Carvo, and many more. Using the PDK transistor and other elements, design engineer make the IC and finally they submit the final design to the fab companies for chip fabrication. Since in the introductions video we are going to use the default analog library to keep things simple for beginners. So we will not include any custom PDK. That's why I'll select just last option and proceed. So find out our newly created library on the library window. Here is our library, but it does not have any cells. We need to create the new cell here. So again go to File menu, select New. This time select Cell View. Now name your cell, for example maybe cell 1, and make sure your view is schematic. It's very important. It's okay. Now we have created a cell. Okay, so this is the schematic window for Cadence Virtual Platform. You can make your circuit schematics on this window to add any device, for example resistor or capacitors or any voltage source. Just go to create an instance since we will use the default analog library. So for that, browse to the analog library. We will include a resistor. Just type R, E and S and the resistor, jump in. Sure that you select the symbol under V window and there is a tiny window on the view option where you can see the symbolic view of the instance. Place the resistor on this window. Again, we need to include our voltage source, DC voltage source. For write down just VD. Look at this is our DC voltage source. Place it somewhere here and press escape key to get out of the sense mode. We can move any components anywhere in this window. For example, just move here and we need to connect the nodes, these components. To connect the components node, just go to create option. Again from there go to where, connect the individual nodes. This one connected to that node. We also need to include a ground because we need a reference point in the circuit. Again go to create add instance and from the name of the ground cell is G and D. And now let's put the ground on this node. Now we have a resistive series circuit. That's how we make schematic in Virtuoso. Now to change any component's value, just select the component and right click and go to properties. For example, here we want to change the resistance value. Similarly, if you would like to change the voltage source value, just right click and go to properties and you can give a disable digit of 5 volts. So until now you have a very good introductions to Cadence Virtuoso. We will learn simulating this circuit and view the voltage and current waveform in the next video. So, select the resistor to change the properties and right click or just from the keyboard shortcut is Q. Change the resistor value is the 1 kilo ohm. Similarly, change the property of the voltage source. We will define that this voltage in term of a variable called Vs. Using the variable in schematics makes the design process much easier. So, we are ready to simulate now. And before simulating, you must check and save. And after that, go to launch and then run the ADL. Now, this window is a simulation center from where we control our simulation. Right now, we have defined of only one variable. We want to bring it here. So, just right click on it and select copy from cell view and the variable will appear here. We would give it to a value 5 volts. Now we will add a simulation engine. Go to analysis and choose. Look at this window, simulation engine window. It will provide you a bunch of powerful simulation engines like and for transist and SP for S parameter and HB for harmonic balance of nonlinear circuits and PSS for periodic steady state analysis and many more. We will run this simulation, so select DC and under this analysis option enable save DC operating point. We will sweep our design variable VS. To enable this option, design variable same variable and write down the name of the design variable. We have defined the name was VS. So just write down VS and then we will define a range of sweep. We will start from 1 volt and stop at 5 volts with a linear step of 1 volt and make sure that the option is enabled because without it you will receive an error message. So this is this simulation engine with a short descriptions and now we are ready to simulate. Before simulations, we will do one more thing. Go to Outputs menu, select Save All. You must enable all options here. Actually, this is very important. This will save all the node currents which can be later used to plot the node currents of the circuits. So after that we will run the simulation. So go to simulation and select this or the quicker way to run simulation is to just click on this green bubble. So simulation is done. But look at there is nothing to show because we didn't define anything. What to show? Usually what we like to see must be defined in this window, this output window. But we didn't define anything here. Okay. Now go to results menu and direct plot and would like to see the current versus voltage waveform. So from this menu select current, select the terminal, select this node to see the current. So this is the current versus voltage waveform. You can see this is quite linear. So it confirms the Ohm's law. Voltage and current have linear characteristics. In the plot, the voltage was swept from 1 volt to 5 volt and the corresponding value of the currents was plotted. Now we can customize the plot property. We can change the color and the width of the curve, and from here we can change the width. We can do many more things like we can change axis properties. If you would like to change the y-axis, just right click on it and select axis properties. Maybe you would like to change the scale of the axis. change to manual mode and give the maximum value of y-axis is 10 milliampere. So the maximum value of the y-axis is changed to the 10 milliamperes. Okay, so now you know many things in Cadence. You can understand the basic things. Okay, so thank you. Thanks for watching.